Welcome to The Explainer. I am so thrilled you're here today because, well, we're going to tackle something you interact with dozens of times a day, probably without even realizing it. Think about it. How often do you hear the phrase, or even say it yourself, oh, just save it to the cloud? You snap a photo, you hit save, and boom, off it goes into the digital ether. But where exactly is it going? Today, we're demystifying that exact process. We're looking right past your screen to uncover the massive, physical reality that's working tirelessly behind your everyday devices.
Okay, let's dive right into this, because the very name, the cloud, is, frankly, a bit of brilliant marketing. I mean, it successfully convinced us that our data just exists in some invisible, ethereal state floating above our heads. It sounds weightless, magical, and completely disconnected from the physical world. But the reality? The reality literally couldn't be further from the truth. There's no magic here, folks.
To put it bluntly, the cloud is simply other people's computers. Seriously. When you save something to the cloud, you are sending your personal data to be stored, processed, and delivered by a sprawling, global network of very real, very physical machines. It's essentially an on-demand system. So instead of relying on that finite little hard drive inside your laptop or your smartphone, you're just renting space and power from massive data centers located all over the globe.
All right, Section 1. It is not in the sky. The physical reality.
And this brilliantly illustrates the contrast between your lightweight, silent smartphone and the heavy, industrial reality of where your data actually lives. These data centers, they are massive warehouses, often the size of multiple football fields. Inside, they are packed to the absolute brim with thousands upon thousands of physical servers, stacks of hard drives, endless rows of networking equipment, and heavy cooling systems. And those cooling systems, they are so incredibly loud, it literally sounds like you're standing on a tarmac next to a revving jet engine. So yeah, it is heavy industry, definitely not a fluffy white cloud.
So who builds and runs these colossal warehouses? Well, primarily, it's a handful of tech giants. You've got Amazon running AWS, Microsoft with Azure, and Google operating GCP. These major players have spent billions building out the physical infrastructure that quietly powers the modern internet as we know it today.
Moving on to Section 2. The journey of a single file, from upload to storage.
Let's make this concrete. Imagine you just took a great photo and uploaded it to Google Photos. What actually physically happens? First, that file travels from your phone across the internet's physical cables and wireless networks. Second, it arrives at a specific provider's data center, say a Google facility somewhere. Third, that digital photo is mechanically written onto a physical hard drive or a solid-state drive sitting in a server rack inside one of those massive warehouses. And fourth, it gets replicated across multiple locations.
Which brings us to this number 3+. Cloud providers don't just put your precious photo on one hard drive and cross their fingers, hoping for the best. No way. They have an almost paranoid level of extreme redundancy. They automatically copy your file to at least 3 completely different physical locations.
Now, to manage all this redundancy, providers use a highly structured geographic system. For instance, AWS divides the globe into what they call regions, like the AP South 1 region located over in Mumbai. But within each of these regions, they have multiple availability zones. And an availability zone is essentially a distinct, completely separate data center. Because your data is replicated across these specific zones, if one data center experiences a total catastrophic power failure, another availability zone steps in and serves your file to your phone instantly. You would literally never even notice the blip.
Section 3. The need for speed. Optimizing delivery.
Now, what's really interesting about this is how data travels. When cloud engineers want to get your data to you faster, they really have to optimize 2 things: bandwidth and latency. Think of your network connection as a physical pipe. Bandwidth is the pipe's width, how much water or data can gush through at the exact same time. Latency, however, is the pipe's length. It's the physical distance the data has to travel, which dictates that annoying delay before the first drop even hits your screen.
So to conquer latency, to artificially shorten that pipe length, providers use CDNs or content delivery networks. Instead of making your request travel all the way across the ocean to a central data center every single time you click something, a CDN caches or temporarily stores copies of files on servers that are geographically right in your own backyard. This is perfectly captured by your streaming habits. As the source material points out, Netflix literally pre-positions popular shows at local servers situated close to your neighborhood, often before you even press play. By anticipating what you're going to watch and caching it nearby, they effectively eliminate the latency. That's what gives you instant streaming without that dreaded buffering wheel. Taking this concept a step further brings us to edge computing. If latency is the ultimate enemy of real-time applications, why even send the data to a central cloud to be processed in the first place? Edge computing solves speed issues by processing the data locally, right at the edge of the network, like right on your smartphone or a nearby local server, exactly where the data is actually generated.
Moving to Section 4, Storage and Computing, breaking down cloud services.
First off, how is the data actually organized inside those giant warehouses? Well, it usually falls into two buckets. First, you have object storage, like Amazon's S3. This stores files as objects bundled with metadata. It's basically a massive flat structure that is absolutely ideal for dumping millions of photos and videos. Then, on the other hand, you have block storage. This acts much more like a traditional hard drive you'd find in your own computer. It breaks data into fixed-size blocks, which is absolutely necessary for running complex, fast-moving databases.
Let's move to how this builds into the services we actually buy. Think of cloud services as a bit of a hierarchy. At the base level, you have IaaS, or Infrastructure as a Service. This is renting raw computing power, like getting bare metal servers from AWS. One step up is PaaS, Platform as a Service. This provides the development tools and app engines for programmers to build things without ever worrying about the underlying servers. And finally, at the top is SaaS, Software as a Service. This is what you and I use every single day. Complete end-user applications delivered right over the internet, like Gmail, Netflix, and Dropbox.
And companies can choose exactly how they want to rent these environments based on their specific privacy needs. A public cloud, like standard AWS, means you are sharing the massive underlying infrastructure with other customers. A private cloud is dedicated hardware locked down for one single organization with strict privacy needs. And a hybrid cloud is, well, exactly what it sounds like. It's a custom mix, keeping sensitive data private on your own servers while using the public cloud for the heavy, everyday lifting. Finally, Section 5, Safety and Scale, the Cloud Advantage.
So why did the whole world shift to this model? The answer really lies in the magic behind the scale. First up, the economics of scale. Because Google, Microsoft, and Amazon are buying hardware in such tremendous bulk, they can spread those massive fixed costs across millions of shared customers. That makes computing vastly cheaper than a company just buying its own servers. Second is virtualization. Through software like VMware or KVM, providers can take one massive physical server and slice it up so it acts as dozens of independent virtual servers. It's wild. It maximizes efficiency to an absolute incredible degree. But what about safety, right? Handing your personal data over to other people's computers sounds kind of risky. But actually, reputable cloud providers secure your data with military-grade encryption. It's encrypted while traveling across the internet using TLS, and it's encrypted while physically sitting on those warehouse drives using AES 256. Statistically speaking, your files are vastly safer heavily encrypted in a guarded AWS data center than they are sitting on a fragile, unencrypted local hard drive in your home office.
So the crucial point here is that this massive global network isn't just for big businesses. It's the invisible engine of your daily life. It is quite literally the cloud in your pocket. Your encrypted WhatsApp messages are routing through Meta's physical servers. The YouTube videos you scroll through are streaming instantly from Google's localized CDNs. Your work documents on OneDrive are sitting securely on Microsoft's Azure's block storage. Even your downloaded Spotify tracks are just cached cloud data sitting on the edge computing device we call a smartphone.
We've traveled a long way today. You now know exactly what it means when someone tells you to just save it to the cloud. You can picture the football field-sized warehouses, the roaring cooling systems, the specific hard drives in availability zones across the globe, and the complex pipelines delivering that data to your screen in mere milliseconds. The cloud really is a triumph of physical, mechanical engineering.
But I want to leave you with a thought to chew on as you go about your day and interact with these amazing services. We've established that the cloud is just other people's computers. So if almost all of your personal data lives inside physical warehouses owned and operated by just 3 massive corporations, who truly holds the keys to your digital life? Thanks for joining me on this explainer. Keep asking questions, and I'll see you next time.